Welcome to the first lesson of Unit 2. Today we're going to be learning about ratios and proportions. A ratio is a comparison of quantities measured with the same units. In this virtual class, there are 40 students and one teacher. The ratio between students and teachers is 40 to 1. We can also replace the word to with a colon. So we can write it students, teachers. 40 to 1. We could also write it as a fraction. 40 over 1. Ratios and fractions represent the same information. They're just written in a different way. So a ratio is written like so, with a colon in between, and we read the colon with the word to. Or we can write it as a fraction, 40 over 1. Equivalent ratios are ratios that make the same comparison. We learned about equivalent fractions in previous lessons, so equivalent ratios is the same idea. There is a common multiple between the two ratios. Suppose a class of 30 students has 6 computers. Then the ratio of students to computers is 30 to 6. To find an equivalent ratio, multiply or divide both parts of the ratio by the scale factor. When dividing, the number must divide evenly into both parts, so no decimals. Instead of finding a lowest common multiple that we would if we were finding equivalent fractions, when we're trying to find equivalent ratios, we try to find a scale factor, which is a common multiple between the two ratios. To state the smallest equivalent ratio, find the largest number that divides into the two numbers in the ratio. This is the same process that we would use when we are reducing fractions. Examples. 2 structures were built out of black and white blocks. So we have structure 1 and 2 here. Write the ratio of black blocks to white blocks for each structure. In structure 1, we have 2 black blocks and 4 white blocks. In structure 2, we have 6 black blocks and we have 8 white blocks. Part B is on the next page. Were both structures built using the same color ratio? Explain how you know. Let's go back to the ratios that we've created. The answer here is no. The first structure is made with 2 black blocks and 4 white blocks. The scale factor here is there are double the white blocks than there are black blocks. But in structure 2, there are 6 black blocks and 8 white blocks. That is not times 2. If these two ratios were equivalent, then the scale factor for structure 2 would also be multiplied by 2, but it's not. So the answer to part B is no. Question 2. Circle the ratios that are equivalent to 3 to 4. Remember, we said that ratios and fractions represent the same information. So fraction 3 over 4 is equivalent to 3 to 4. 6 to 8 is also equivalent. If you multiplied 3 by 2, you would get 6. And if you multiplied 4 by 2, you would get 8. So 3 to 4 and 6 to 8 are equivalent ratios. Draw a picture to illustrate a ratio that is equivalent to 2 to 5. Explain how your picture illustrates this. Let's draw 2 red squares. And so that covers the 2 part of the ratio. And then 5, let's draw 5 blue squares. Relationship of equivalent ratios. To find relationships in equivalent ratios, look for multiplication or division relationships in the ratio. Let's look at method 1. You can find a relationship within one ratio. The scale factor between 5 and 20 is 4. 5 times 4 is 20. So I'm going to use the same scale factor to find the relationship between the next ratio, because this equal sign here tells me that these 2 ratios are equivalent. So I'm going to use the same scale factor for both ratios. So I'm going to multiply 35 times 4, which is equal to 140. Let's try another one. Since my n is my first part of the ratio, we have to divide in this example. So to go from 21 to 7, we divide by 3. So I'm going to use the same scale factor here. So 42 divided by 3 is 14. And finally in C, to go from 100 to 1,000, we multiply by 10. So we're going to use the same scale factor in the first ratio. So K is equal to 10 times 10, which is 100. You can also find a relationship between ratios. To go from 5 to 35, we multiply by 7. So I'm going to use the same scale factor to find the relationship between the 2 second parts of each fraction. So 20 times 7 is equal to 140. What's important to remember is that you're using the same part of each ratio when finding the relationship between ratios. So 5 and 35 are both the first half of the ratio, and 20 and D, which we found was 140, are the last part of each ratio. So when you're finding the relationship between ratios, ensure that you're using the same part of each ratio to find the scale factor. Let's practice again in the next question. To go from 21 to 42, we multiply by 2. So to go from 7 to n, we're also going to multiply 7 by 2. Seven times 2 is 14. And the next one, so to go from 100 to 10, we divide by 10. To go from 1,000 to k, we're also going to use the same scale factor. (1,000) divided by 10 is 100. In method 3, we can use cross multiplication. Like we talked about in the beginning of this lesson, ratios represent the same information as fractions, but just in another way. So we can convert our ratios into fractions. So the first part of your ratio is going to be your numerator of your fraction. And then the colon is going to turn into a fraction. And then the second half of your ratio is going to be your denominator. And that's equal to 35 is going to be my numerator of my second fraction, divided by d will be the denominator of my second fraction. So now we've converted our ratios into fractions. And now we can find d by cross multiplying. When you cross multiply, you make a cross or an x with your numerators and denominators. The numerator 5 is going to be multiplied by the opposite denominator d, and numerator 35 is going to be multiplied by the opposite denominator 20. So 5 times d is 5d, and that's going to be equal to 35 times 20. And then I'm going to simplify my right side of my equal sign. $35 times 20 is 700. I'm going to divide both sides by 5. D is equal to 140. Let's try this again. C to 20 is equal to 18 to 15. I'm going to convert these into fractions. Next, I'm going to cross multiply. So opposite numerator is being multiplied by opposite denominator. 15 times c is 15c is equal to 18 times 20. Then I'm going to simplify my right side. 18 times 20 is equal to 360. And then I'm going to divide both sides by 15 to isolate for c. C is equal to 24. Let's try the next one. 7 to 21 is equal to n to 42. I'm going to convert 7 to 21 into a fraction and equate that to n over 42. Cross multiplying, 7 times 42 is equal to 21n. This time my variable is on the right side, which is fine. 7 times 42 is 294, which is equal to 21n. I'm going to divide both sides by 21. $14 is equal to n. D, 12 to w is equal to 12 over w. And 21 to 28 is equal to 21 over 28. Cross multiplying, 12 times 28 is equal to 21w. 12 times 28 is equal to 336. I'm going to divide both sides by 21. 336 divided by 21 is 16. Let's practice some more examples. Create an equivalent ratio using a scale factor that would make the numbers in the ratio larger. Determine an equivalent ratio by multiplying. So we want an equivalent ratio, but the next ratio needs to have larger numbers. So what if we multiplied both parts of this ratio by 2? Then our equivalent ratio would be 10 to 4. Let's try B. Let's multiply both parts of our ratio by 4. Then our equivalent ratio would be 40 to 12. And finally, let's multiply both parts of our ratio in C by 10. Then our equivalent ratio to 4 to 7 would be 40 to 70. In part 2, it's asking us to divide, so we want a smaller ratio. Let's divide both parts of our ratio by 2. So our equivalent ratio to 6 to 10 would be 3 to 5. In B, we can divide both parts by 100. So our equivalent ratio would be 5 to 15. And in C, we can divide both parts of our ratio by 5. So our equivalent ratio would be 35 to 25. There are some homework questions in the workbook PDF for you to try. If you have any questions, either join today's Zoom or message me.